Yeah, good evening, everyone. I'm Amruta, and it's my absolute pleasure to extend a warm welcome to 2 week short-term training program on AI and ML coding using generative AI, which is powered by Indian Science Technology and Engineering Facilities MAP. So this program is being conducted from 24th March to 4th April. We are delighted to have you all on this exciting learning journey. So today we are going to learn more machine learning facts using generative AI. So before we begin, here are some important guidelines to ensure smooth and effective session. So while joining, make sure to um, share your name and affiliation in a live chat. Use a laptop for better learning experience, especially during hands-on activities with our experts. Filling up the filling up the feedback form during each session is compulsory. The form link will be shared in YouTube chat box. So let me take a moment and introduce Academy Innova World. So our academy is dedicated to fostering interdisciplinary learning and research through advanced training programs, workshops, and industry collaborations. Our mission is to bridge a gap between theoretical knowledge and a practical implementation, empowering learners to excel in emerging technological domains. I also extend a heartfelt welcome to our esteemed guest for today's session, Dr. Arunava Majumdar. We are grateful for his presence and look forward to his valuable insights as he takes over today's session. Wishing you a great learning experience. With that, let us move ahead with today's session. I hope all of you have a productive and enriching learning experience. Over to Dr. Arunava, sir. Please, sir.
Good evening, all. Welcome back again in today 2 weeks program of AI and ML code generation with generative AI. And I today I start with the advanced level of machine learning algorithms like decision tree, okay, random forest algorithms, and the other ML algorithms, whatever the algorithms are there. So before starting the advanced level, let me discuss with whatever we have discussed till now. And so far, what we have discussed uh, about the regression and classification problems that are based on the purely statistical methods like linear regression with one independent and one dependent variables. Okay, let me uh, share my screen first. Okay, so whatever we have learned, we first learned that what is categorical data, what is continuous data. Already we have learned this one. Okay, we also learned that what is regression and what is classification. Okay, we also have learned what correlation coefficient is between two variables. Okay, and all these things are basic. Whatever we discuss, regression, classification, all are based on supervised learning. Supervised learning. Okay, so this regression, classification, everything, it actually is under the supervised learning. I did not explain unsupervised learning till now. And in unsupervised learning, one of the important methods is there, which is called clustering. So I will discuss the clustering later, but the basic knowledge about regression and classification I already explained. So in regression, we only use regression uh, in only that case where the dependent variable is having continuous data. Okay, continuous data. And we apply classification, that is we categorize this as a classification problem if our dependent variable is having the data that is categorical data. Okay, so these two are the means a reason, means the cases where we apply regression, where should we apply the classification. These are the cases for that. Okay, in regression, we already discussed about linear regression. We discussed about multilinear regression, and in classification, we discussed about logistic regression. We discussed about logistic regression here. So these methods, linear regression, multilinear regression, logistic regression, all these methods are statistical methods. Also, we use this method in machine learning, but in statistics, they are basic statistics method where a mathematical equation is formed. Okay, in linear regression, multilinear regression, a linear mathematical equation is formed, like y equal to uh, a plus b1 x1 plus b2 x2 and so on. Okay, so if x1 x2 x3, what are these? These are the independent variables, and y is a dependent variable. Okay, and a is a constant, and b1 b2 are all the coefficients of x1 x2 x3, and all the independent variables. Okay, so we need to find out the constant, that is the intercept part, all the coefficients parts in these statistical methods. That is, we need to find out the mathematical equation here. In logistic regression also, we need to find out an equation like a plus b1 x1 plus b2 x2. But since the variables are the outcome variable is categorical type. So, and especially in binary category, logistic regression is used in uh, cases of binary category, that is 0 1 1, yes no, on off, this type of cases. Okay, so so we need to pass this value y, the y value, into another function which is 1 by 1 plus e raised to the power minus x. Okay, what is called the logistic function. And this function is gives you a probability value which is between there is a value between 0 and 1. Okay, between 0 and 1. And this 0 1, now we will categorize if your value is greater than 0.5, sorry, yes, 0.5, then we categorize it as a greater than or equal to, then it is 1. And if it is less than 0.5, then we categorize this one as 0. And this is how we categorize the values 0 and 1 based on the probability values. Okay, but both the cases equation is formed. Now what is many, there are many drawbacks on these statistical methods are there. Overfitting problem is there, underfitting problem is there. Okay, and in linear and this linear kind of cases, many constraints are there which you need to satisfy according to the data set. Okay, the residual of the fitting, they should follow the normal distribution. Okay, normality criteria is there. Also autocorrelation criteria is there. Okay, so there's many criteria there, and due to which many of the times in very large data sets, in nonlinear data sets also, this kind of statistical methods, it doesn't work well. Yes, one thing I didn't discuss in this relation, this another thing also in statistical method, nonlinear regression is also there. So what nonlinear regression is? Nonlinear regression means here we are fitting a linear type of equation. In nonlinear regression, in nonlinear regression, we need to fit a nonlinear type of curve in the data set. Okay, so if we can understand that yes, the data set is having some nonlinearity or linear curve doesn't fit well, so we can use the nonlinear equation also. Now there is not a single type of nonlinear equations. There are multiple type of nonlinear equation, like polynomial with degree more than means greater than or equal to 2. There is equation of exponential, okay, logarithmic, okay, inverse. So many other, so we can form in polynomial greater than or equal to 2. You can have the equation like this: y equal to a plus b1 x square x1 square plus b2 x2 square, okay, plus dot dot dot. Now again p, let us suppose only two variables x1 and x2 are there, okay. So for these two variables, now it is b3 x1 x2 plus b4 x2 x3, sorry, x1 x2, and x1 b5 x2, this kind of variable. So as the number of variable increases, okay, the equation also it increases, and the length of the equation also increases. Okay, so all type of means in nonlinear equations, if it is polynomial, if you are considering only degree 2, then you need to consider all means general type of degree 2 polynomial here. Okay, if it is degree 3, the general formula of polynomial equation of degree 3 with two or more variables, so which will be a very, very big equation will be formed there. Okay, so in logarithmic function, let us suppose if it is only one dependent and one independent variable, it should be like this: y equal to a log uh, bx, this type of things. Okay, um, and if it is there are many means variables are there, then it will be like this: y equal to a1 log b1 x1 plus 8 2 log b2 x2, okay, plus c. These type of equations may be there. So these equations you can form equation as you want. Here you can form, you can just delete the term x1 into x2. You can only form the equation by using the term x1 square x2 square, but you can delete the terms x1 x2 x1 x2 like this. Okay, linear term you may delete. Okay, so the entire model depends on your assumption what type of equation you will consider. There is no means yes, of course, the this is the polynomial general form of the polynomial or general form of the equation is there, of course, but the if you consider the general form, your equation will be that much bigger. Okay, so it also increases the time of computation also in that cases. So somewhere this type of means statistical methods, purely statistical methods, where some mathematical equation, either linear or nonlinear, okay, equations is formed, they lack somewhere. That may be so, still doing after getting the equations also, we cannot find a proper curve which fits best. Okay, we can also see that in the last class we see that our accuracy is very less after using the logistic regression also. Okay, so in that cases, okay, what we can do, we can modify our method and we can use the advanced AI, sorry, ML algorithms. Okay, there are many ML algorithms are there where this overfitting and underfitting problems can be removed. Okay, can be not removed, not 100% cannot be removed, but we can say that yes, somewhere we can, the outliers can be managed. Okay, somewhere we can easily find out, we can easily fit the proper model. Okay, without having any proper mathematical equation. So now we start with a very basic, not basic, but very useful a tree method which is called decision tree. And one of the most popular, I can say, this method is decision tree. Okay, let me give you an example what decision tree is. Before starting the decision tree, you need to understand what graph is. Okay, and graph a tree. If I say tree is basically a structure, a particular structure of a graph. Okay, what graph is? Graph, it consists of some nodes or vertices and edges. Okay, now what vertices is and what edges is, let me give you a very small example here. Let us suppose that I want to form a network from my home. This is my home and this is my university. Okay, this is station, rail station. This is bus stop. Okay, and this is a market. Okay, now let us form a network of roads. Okay, so these roads are connected. These roads are connected like this. Okay, this particular network is called graph. So which consists of some vertex. These points or nodes are called vertex. Okay, so this network, in this network you can see how many vertex are there. 1, 2, 3, 4, 5. 5 vertices are there. And what are the edges? 1, 2, 3, 4. Look at the edges. These edges are not directed. There is no direction of the edge. So you can move anywhere. Any direction you can move through these edges. Okay, so how many ways you can reach university from your home? If this is your starting point and university is your destination, then you can go to this direction and this direction. You can go this direction, then go here and then here. Okay, this is the two ways you can reach university. Okay, there is no other way from home. Okay, so this is a network, and the shortest path or shortest network can be found by using different algorithms. If the graph is weighted, if we know the time between any 2 points, the reach means the communication time between any 2 points, we can easily find out what in which way we can reach the university in minimum number of time. Sorry, in less time. Okay. Now, what tree is? Tree is also a graph. Moreover, we can say it's a data structure, okay, where no circuit is formed and each and every vertex is connected. It's a connected graph, but without any circuit. So, what circuit is? Look at this. If any loop is formed, then it is called a circuit. If any graph doesn't form any loop, then it is called a non-circuit graph. And also, if a connected graph without any loop, then we can say it is a tree. So what is the definition? This is a definition of tree. This is a tree graph. Okay, how many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices and 1, 2, 3, 4, 5, 6, 7. 7 edges. So this structure is called tree. You can see all vertices are somehow connected. If you start from any vertex, you can reach any other vertex. Okay, somehow they all are connected. Yes, not directly connected, but they are indirectly connected. So this structure is called tree. Now, what decision tree is? Decision tree is basically is formed where this tree kind of structure, a network is formed, and we can easily say that our means of which direction we can have our proper decision. Let us suppose a very small example I am giving you. uh, a person, okay, whose salary is greater than 25,000, and a person, suppose this is a person, this person will be sanctioned a loan. Only the condition is if he is more than 25 years of age and having 25,000 salary. Okay, so how can you draw a decision tree? Okay, so there is only two decision is there, yes and no. Yes means loan is sanctioned, no means loan is not sanctioned. And what are the condition of sanctioning loan? Greater than 25 years and salary is greater than equal to 25,000. Okay, so how can you draw a decision tree based on this? Okay, so decision tree will be like this. You can create, means there are two cases you can see. First case is age, second one is salary, third one is decision. So age is greater than 25, less than 25, greater than equal to. Salary is greater than equal to 25,000, and the decision is yes, loan is sanctioned. But if it is less than 25, then less than 25, greater than equal to 25k, but it is also yes. Okay, but less than 25, less than 25k, no. So you see this one, if you see this decision tree, okay, so sorry, this data set, see here, salary more than or equal to 25k, in both cases the decision is yes. But if it is less than 25 years of age and less than 25k salary, then only the decision is no. Okay, so how can you form the decision? If we start with age as our first node, this is called the root node. Okay, and step by step, age is there as two steps, greater than equal to 25 and less than 25. So greater than equal to 25 age, we need to sorry, less than 25. If it is greater than equal to 25 age, and yes, another thing, there is also greater than equal to 25, but salary is less than 25k, then also it is no. Okay, so uh, greater equal to 25 but salary is less than 20k, 25k, it is no. So all less than 25k salary, it means it is no. And greater than 25, let us suppose that this is not there. So look, I am shortening the tree, means I am if only these three data is given, then let us start with the salary first. Why I am starting with the salary? I will give you the explanation for this. Look at this. If the salary, if it is 25k, okay, no issue. We will be getting, he or she will be getting the decision as yes, irrespective of the age. So if the salary is greater than or equal to 25k, then the decision is yes. But if the salary is less than or equal to 25k, then the decision is no. Okay, less than 25k, then it is no. But if you start with the age, then what happens? In age, greater than equal to 25, less than 25. So less than 25 age, then we need to check the salary. We need to check the salary. If the salary is greater than 25, less than 25, it is yes, but it is no. But if it is greater than equal to 25 is age, and salary also. Then you can see greater equal to 25, there is only one data is given. Okay, so insufficient data. So in that case, we can only say here it is either yes or no, but greater than equal to 25, and this is also greater equal to 25. So we can say here simply greater equal to 25. Since it is yes, we can put here yes, but basically you can see the data is itself is insufficient, because for greater equal to 25, what kind of means there should be two cases: either salary is greater than 25 or less than 25 or not. Okay, so in that cases we can say that yes or no, but here the data insufficient, so that is why we can move here. Since it is greater equal to 25 case, it is yes, so we put it like it. But we can reduce this decision tree like this. So salary less equal to greater equal to, if it is less equal to, it is surely no. If salary is greater equal to, then it is surely yes. Okay, so this thing it can be done. So as your target, it will be as small decision tree as you find. Okay, then your decision, your accuracy of the model will be that much accurate. It means that accuracy will be increased for smaller decision trees. Okay, so let me now, in that cases, I am going to give you an example of decision tree here. This is a data set, and there are this is your decision, means the target. This is independent variables. These are the independent variables: x1, x2, x3, and x4. Okay, so what kind of problem is the regression or classification? Since the outcome, it is the yes no type, so it is categorical. So we see that it is classification problem. Okay, now what kind of decision? So look at this. It is outlook is sunny, temperature hot, humidity is high, wind is weak. Then should I play tennis? No. Outlook sunny, temperature hot, humidity high, wind strong. Should I play tennis? Again, no. And so on. So what kind of decision tree we can get? Okay, so we can get a decision tree like this. This one. So you get the decisions like this. Now these decisions tree is formed according to the previous data set. Okay, this data set, and since the data set is very large, making a decision tree like this, okay, by using hit and trial method, that is which column, either salary or which feature, salary or age, we should keep as a first position, or it is called the root node or root vertex. Okay, the first feature in a decision tree is called the root vertex. So which one should be considered as the root vertex, and which one the next vertex? It there is a calculation which is called the Gini impurities. I'm not going to discuss all of these mathematical things here. It will just means because we do not have the scope of the heavy discussion on deeper mathematics. We are going to discuss about the code generation. So that is why only the basic things and what is necessary for you, you need to learn only that. Okay, in this class only. So here the root node, it is considered as outlook. Okay, outlook, it is considered as root node. So outlook, there are, you can see sunny, overcast, rainy. Okay, so three categories are there: sunny, overcast, rainy. Now if it is sunny, then we you can see we check the humidity then. Okay, if it is sunny, then it is checking the humidity. You can see if it is overcast, outlook is overcast, then play tennis is yes. Okay, why? Because you can see here it is overcast, outcome is yes. Overcast, outcome is yes. So only two overcast is there. In all these two overcasts, the outcome is yes and yes. So that is why for overcast we can just stop the algorithm here and we can say easily, if outlook is overcast, then of course the decision is yes. We no need to further proceed with this decision tree. Okay, but if the outlook is sunny, then we will go for the humidity. But okay, so if it is sunny, why shouldn't we go for the temperature? This is another question that should be decided by using the Gini impurity calculation. Okay, so I'm not going to discuss this. If the Gini impurity is high, then that is why the humidity is considered here. Now the humidity is high and normal. There is two categories: humidity either high or normal. Only two categories are there. If it is humidity is high, then it is no. Humidity is normal, then it is yes. Okay. Now if we go for this direction, then our decision is no. If we go for this direction, then our decision is yes. Okay. If we go for this direction, of course the decision is yes. Okay. Now the next one is rainy. Now in case of rainy, we will then check the wind. Okay. So if it is wind either weak or strong, only two categories are there. If it is weak, then yes. If it is strong, then no. Okay, now if now this is our decision and this is our input variables or the independent variables: outlook, temperature, humidity, wind. Okay, now if somebody gives you outlook as sunny, okay, temperature as suppose hot, okay, temperature hot, humidity normal, okay, and wind is weak. If we put these parameters, then what should be our decision? Okay, so let's go to the decision tree now. So sunny, so this is let us outlook is sunny, then our direction is this. Then hot, so sunny and hot, there is no hot here. Okay, sunny, then check the humidity, normal, humidity normal. Then check wind, wind is weak. Okay, so wind is weak. Look, wind is weak here. So here, if the outlook in this case only sunny is there and humidity is there, if we are going to this direction, we will only check sunny and humidity, whether the weather is sunny and the humidity is normal or not. There is no other cases we should check here. So here the decision is basically yes. Okay, so and the direction is this one. This is the direction here. Okay, we don't check any other cases. Now if the outlook is overcast, so except sunny, if we put here overcast and the other parameters we have put like this: hot, normal, weak, no need to check anything. If it is overcast, if it is overcast, directly the answer is yes. Okay, we don't check any hot, normal or weak, anything, nothing is required here. Okay, so this is how the decision tree works. Okay, so now let us go to the chat GPT again. and let us generate a data set, and let us find that whether means how the decision tree code can be formed, and how we can put this code into our own platform and check the result. Okay, so metrics are same. How to check the accuracy? Metrics is the same. Since it is a classification problem, so we check the that matrix, which is the confusion matrix. Okay, accuracy, precision, F1 score. Okay, all these metrics, whatever we have discussed in the last class, you can see the metrics here. Uh, yes, these are the metrics: accuracy, precision, recall, specificity, F1 score. All these matrices will be there, which we need to means find out. And these values will give you whether your model fits better or not. Okay, so let's go to the chat GPT again. Okay, let me stop the screen sharing. Screen visible. Let me open some other, that is Gemini and DeepSeek also. If ChatGPT doesn't work, then we can put the code in DeepSeek to perform some coding. Okay, let's first generate a data set. Okay, I'm directly generating the data set using the ChatGPT, and I am just directly putting that for which purpose we are using it. Okay, so generate an Excel data set. Okay, data set is generated. First, let me show you the data set, what it generates, because I also don't know which data set it generates. Okay, so it generates a very small data set with only 11 data sets are there. Okay, let me increase the data set. It is very small. Let me giving you 100 data. Yeah. So now they modified the data set. First is age, second one is income, education, past purchase, will buy or not. Okay, 100 data sets are generated by it. Okay, so let us perform a decision tree model, and I will ask the ChatGPT to code with the same. Okay, okay, so let us first read the code. You can see all matrices are defined here, and level encoder is also used, and classification, yes, but the plottings are not defined here. Okay, plottings means I couldn't find the confusion matrix. Confusion matrix is printed, but no heat map is generated. Let me modify the code again. So modify with confusion, modify with adding confusion matrix heat map. Okay, now it's done. Let me copy and paste the code here. You can also run the code from here, but the code will not run because the decision tree, because we are running this code based on the Excel file, and the Excel file is basically in our computer. Okay, so here that Excel file cannot be faced by this code, so that is why it will not run. So let me open my platform. Okay, I am eliminating the previous dataset here. Now let me first um, okay, if your dataset is open in Excel file, first turn it off. What is the name of the dataset? Decision tree large dataset. Okay, first turn it off because it may create some problem. So let's save it first. Turn this, close this one also. Okay, so before running the code, okay, yes, this one. Before running the code, just close all the Excel files. If the code is, if your dataset is open in any Excel file, first close the Excel file, otherwise the code will not run. Okay, so then now copy as path. Okay, now go to your downloads where the dataset is actually downloaded. Copy the path from here, copy as path, go to the code, and now modify the path here. Okay, so modify the path. This is my path, and also I need to use R here because we am using the VS Code, so I need to use R. If you're not using VS Code or using any other platform, then maybe the R is not required here. Okay, now you can see our income, education, and past purchase. All these things, these variables are categorical, that is in strings, in characters. Without encoding the value with any digit, either 0 1 or something. Okay, any category means 0. If it is two categories, then 0 1. Three categories, then 0 1 2, like this. So without encoding the value in a numeric value, with a numeric value, the code will not run. So that is why we need to encode it. Okay, So encode for the encoding purpose, we need to use the sklearn pre-processing, and we need to import label encoder function. Label encoder is the function where the categorical data can be encoded with the numeric values. Okay, so we call the function label encoder, and then the df column, that is the we use the fit transform df column. So and we use this label. This is another label encoders, means this is a new, okay, feature we added here. Okay, and that is the label encoder here. And in this label encoder, in column, we use the LE, where LE is the label encoder function which is called here. Okay, so now no need to means worry about all these kind of things, because this is generated function, so I'm not going to explain all these things here. Okay, so here label encoder fit transform y, because y will buy or something, because will buy is the features what is our means a target. Okay, so will by is our target variable. So that is why we also need to you need to transform the variables, means will by means yes or no, as 0 and 1. So label encoder function will also be called in will by cases. Okay, so that is why we use label encoder fit transform y. Okay, why it is use dot or fit transform, I'm not going to discuss all of these things. It is not required in this particular cases. You only need the code. So this code is added here, and you can see here. Yes, this is important. How many percentage you are going for the means data percent of data sets going for the testing? 0.2. It means that 20% is going for the testing and 80% is going for the learning purpose. Okay, and now this is the function decision tree classifier. You remember that since our data is a classification, our problem is classification problem, that is why we use decision tree classifier. If your data is a continuous data, your target variable is continuous, and you are performing regression, decision tree regression is also there, also we can use. Okay, which is you have to use call another function, you have to import another function for that. Okay, and this is the for the accuracy level. Okay, so all accuracies you can see: accuracy, precision, evaluation, model evaluation, accuracy, precision, recall, F1 score, confusion matrix, and classification report. Everything is there. And then we print all these reports, and then we make the figure for confusion matrix. Okay, let's run the code now. Yeah, the code is run. So after running the code, this is the confusion matrix is formed. Now I already told you that my means second row values are not displayed due to some inefficiency of my computer. Otherwise, means whatever the software it is installed, maybe there is some glitch in software. There is a second row values are not displayed ever. Only the first row values are displayed. However, you can just delete it. You can get it from here. You can see what the confusion matrix is: 3836. Okay, F1 score, recall, precision, accuracy, everything is there. Okay, this is the classification report, also it is shown. Okay, but it is good or not? No, not at all. Accuracy here only 0.45. Okay, and accuracy you can see only 0.45, precision also 0.43. Not at all a good score we can find. Also in the confusion matrix you see here 3836. Okay, now if I generate the code again, yeah, let me copy and paste it here. Let me explain the confusion matrix. Okay, so here you can see This is our confusion matrix, and we shorten it somehow. All these predicted values are given here. Let me write down the original confusion matrix values here. 3836. Okay, so the values are 3, so 3 is there. This is 3, 8, 3, 6. These are the values. So out of this 3836 values, you can see, so actual value, okay, this is our actual value. Yes, no. And this is our predicted values. Yes, no. So when the actual value is no, predicted value is also no. How many outputs are there? Only three outputs are there. Actual value no, and means both no and no. Both cases means we predicted correctly. Actual value no, our predicted value is also no. So we have predicted correctly how many values? Only three values. Okay. Actual value is no, predicted value is yes. How many values are there? Eight values. Okay, let me show you the, it's not, yeah. So what is the value? 8. Okay, so actual value is no, and predicted value is yes. It means that it is false. Uh, Actual value no, false positive. So false positive, it means actual is no, but we predicted is yes. It means we are predicting wrong. So wrong prediction is 8. Actual yes, predicted yes. It is called true positive. So true positive value is 6. The true false positive value is greater than the true positive value. Okay. Actual value no, and predicted value is also no. So false negative. This is our false negative. Actual value yes, predicted value no. It means true negative. So true negative, false positive. Both cases you can see the values are high. So the actual means correct prediction, the correct prediction is low, but incorrect prediction is high. So confusion matrix itself says that the accuracy is not good here. Now go for the accuracy level. Okay, if we go for the accuracy level here, also you can see here the level of accuracy, it is very less, it is 0.45 only. It is not acceptable at all. Okay, but why this happens? You can say that this happens because your data set is very small here. Can't predict it properly if the data set is wrong. The data set is very small, only 100 data set is, and we are testing it with only 20%, means that only 20 data sets. Okay, so you see that only 20 data sets. Okay, 8 plus 6, 8 plus 6 plus 3 plus 3. Okay, 21. Yes, 21. However, one data set, one is increased here. So 20 or 21 only, but we are testing it by using only 20 or 21 data set. Okay, not more than. So if the data set is large, if the data set is suppose 1000 data sets are there, then we can have almost 200 data to test for the testing purpose. Okay, and 800 data for learning purpose. So that maybe the accuracy in that model may be higher in that cases. Okay, so can we reduce this means this means this kind of inaccuracy, and can you increase the accuracy? Okay, yes, there are some other models are also there. We will explain. So this is a decision tree. In the next class, we will use a random forest. Okay, which is the, we can say that it is a higher version of the decision tree. One decision tree, it is split into many sub trees to means if the trees to means instead of making a very large tree, we will be dividing a large tree by using smaller trees, and we can form a forest which is called the random forest, and then we apply the same decision tree for each and every tree, and we will then accept the highest values, means the highest voting values in if the yes is the highest number of yes is there, and less number of no is there, then we will say that yes, the answer is yes, like that. Okay, so in that cases, maybe the accuracy, some many cases the accuracy will be higher. So we will use the random forest in the next class. Okay, so this is the all over means idea of the decision tree, and this is how you can modify your code, you can perform, you can generate the code for decision tree. Also there is some decision tree regressor is also there. Okay, if you are having any regression means continuous data set to perform any regression model, okay, you can also perform this one. Okay, but in regression case, confusion matrix or f1 score accuracy, this will be not the matrix for matrices for regression purpose. In regression, what are the matrices to check the model, to check the accuracy of the model? R square value, MAC, RMAC, MAE. These are values are there, and also you can check the means scatter plotting is are there. Okay, how fit you can check the regression line with your predicted value and your original value. You make a regression, linear regression based on that. Okay, so that things are there. So confusion matrix is applicable for classification purpose, not for the regression purpose. Okay, so also we will perform the decision tree and random forest regression in the next class. Okay, so this is all for today. Anybody is having any question, any doubt, please ask.
Yes, sir. So there are some questions in the chat box. As of now, I can see it. So there is a question that if predicted will be no, then what will happen? So can
Uh,
you check the chat box? So if
yes,
predicted will
yes.
be no, then what will happen?
Just let me check the chat box.
Yeah, I think as you are talking about this method, it was about that. So it is in the YouTube chat box.
Yeah, yeah. Let me check the YouTube chat box.
Yeah. So is there any other questions? So requesting participants to please
Please,
write down the
if the
question.
predicted will be no, then what will happen? Predicted will be no. I can't understand the question. Predicted means predicted both yes and no, both predictions will be there. Okay, you can see both predictions will be there. Check the matrix here. Okay, the predicted values, yes and no, both cases are there. This is no and this is yes. These are predicted values. And how many no are predicted? 3, 3. Total 3 plus 3, 6
So
predictions are no.
there is
But
a
out,
clarification. If is it
yeah,
false negative or positive negative?
no, false, false. Uh, false negative. As actual value is no, it means we will use false, and our predicted value is no. No, no means false negative. Okay, no and no. Here you can see the box, this particular cell. This particular cell is having no and no, right? Actual is also no, predicted is also no. So both are no, no, then it is called false negative. Okay, FN. Both are true. This is yes and this is yes. Both are yes. This is yes and this is yes. So this cell is yes yes cell. If the cell is yes yes cell, then we will call true positive. No no cell, we will call false negative. Okay, any other doubt?
Okay. So I think it has been clarified, and so we can't find, as of now, we can't find any other doubt. So as you know that in the chat box that feedback link is active. So before you leave the session, make sure you fill up the feedback form. And, so as of now, no questions are there. Many have mentioned that's clear. As of now, we can't find any questions.
Okay.
Okay.
So
So
can we wind up the
requesting,
session now?
yes sir. So requesting all the participants, please do fill up the feedback form, and tomorrow we'll continue the session. And if you're looking for the video link, this same link is active. So for your further or the future reference, you can follow up the same link. All right. So you can refer the same, and make sure of that. Please do fill up the feedback link. Okay. Thank you so much. Thank you, everyone. Hope you are enjoying and learning this session. Good night, everyone. Thank you.